Namaste. Let's continue the topic similarity. So in the last two videos we have discussed about the similar figures and the similar triangle. Just a quick recap of that. Similarity, two figures are similar if one is enlargement of other regardlessly of their orientation. Okay, if you remember in the last video we discussed about if two triangles are similar, they are in the same proportion. So now if you observe and if you remember that the triangle is increase or decrease by a certain proportion. Now if you see, if I keep this scale factor as 1, means both the triangles are same, equal. But yeah, definitely if you'll see, the orientation is different. For your uh, understanding, I have kept one of the side length, this as 4.57, this is equals to, see, if I change this side length, the other side length will also change automatically. Okay, now let's suppose if I increase the scale factor. So if you see, the scale factor is increased, now the proportion is increased, means the triangle is getting bigger and bigger because we are changing the proportion. Okay, now if we decrease the proportion by 1, if you see, now the triangle will be getting smaller and smaller. Okay, now let's try to place one above another, just somewhere around. Just simple. Okay, now if you say this is similar to this, now if I take this to 1, exactly overlap, means these two triangles are congruent. Now if you increase the size by 1, so we have seen this kind of examples. Now one triangle can be above other. Now if you decrease the size, so it would be, if the scale factor is less than 1, that the given triangle would be smaller than the previous one, and if the scale factor is more than 1, then the given triangle would be larger than the previous one. Now the thing over here is orientation can be anything. Now we can change the orientation somewhere over here. But if orientation is changed, is there any change? See, these two triangles are in different orientation, but the scale factor is same. So these two triangles are congruent. I can place it anywhere around. We can change the shape. So if you remember what we did in today's example, you have to just check the orientation of one of the triangle and try to arrange the orientation of the other triangle in the same form. Then it would be easy for you to calculate the corresponding sides and find the ratio. Clear? Thank you. I hope this visual representation helps you understand the concept in better way. Thank you very much for watching this video. Bye. Okay, now the properties of similar triangles and similar shapes. If two figures are similar, then the corresponding sides are in proportion. This means that the length of the sides will be increased or decreased by the same ratio. To establish that the two triangles are similar, we need to show that they are equiangular or the corresponding sides are in the same proportion. Okay, now let's understand why we are studying similar triangles. What's problem we are going to solve using the concepts of similar triangles. The properties of similar triangles have been known since ancient times, but even with the technology, advanced measuring instruments available today, similar triangles are the important for finding the height and distance between which would otherwise would be difficult to measure. Let's suppose if you want to understand the application of similar triangles, we can see similar triangles are applied when we have to calculate distance between the two objects. Far means, let's suppose if you have to calculate the distance between the sun and the earth. In astronomy, in physics, in different branches, we apply the concepts of similar triangles. Even in mathematics, trigonometry is a topic where we apply the concepts of similar triangle, application of trigonometry. Or let's suppose if you have to calculate the height of a given building, to measure the height of the given building, we can use the concepts of similar triangles. Okay, to help you understand on this, let's see some basic examples on this, then we'll move ahead to the real life application of the same. Okay, Now show that the figure poses similar triangles. So let's consider this part, triangle. So it's always to identify two different triangles in the given sketch. So if I observe over here, now I have one triangle that is ACE, and I have other triangle, I just separately draw it, that is BD and C. Are these two triangles similar? Just forget about this line now. Now we have these two triangles ABC, ACE and BCD. This angle is equals to this angle because both this are same common angle for both the triangles. And if you see, angle A is 90 degree and angle B is also 90 degree. So two angles, two corresponding angles are same. So we can say triangle ACE is similar to triangle BCD. Now just what would be corresponding side of AC? Yes, the corresponding side of AC would be BC, corresponding side of BD would be AE, and corresponding side of CD would be CE. Clear? This part? Okay, now just pause the video and try for the triangle BCD. Okay, yourself. Then we'll discuss this part. Okay, now let's go for triangle. Let's look out question number E. There are two triangles, so if you identify, now if you want to change the orientation, so I'll just change the orientation with the same, I will keep it this way around, the same as our main triangle. So this vertex is L, in the L the base is J, so I'll write it down this J, and this vertex is K, so I'll write it down this is K. Okay, now say this angle is equals to this angle, yes or no? Because these two are vertically opposite angle. So we are considering this as a triangle, and I have just changed the orientation of this triangle over here. So these two are vertically opposite angle. Now if you remember, these two sides are parallel. Now this is your transversal. So this angle must be equals to this. Reason, it's forming a Z over here. We can say alternate interior angles. So which angle is equals? J. So this angle means this angle. I am just marking with 3 dots. This 3 dots is equals to this. Now if you see this, compare this triangle and this triangle. This angle is equals to this corresponding, and this angle equals to this. So two angles of a corresponding triangles are equal or equiangular. We can say triangle LKJ is similar to triangle LMN. Now just you have to observe the corresponding side. So corresponding side of LM would be LK, corresponding side of MN would be KJ, and corresponding side of LN would be LJ. Clear? Similarly, you have to observe. Now if I draw, see this triangle ACE. Now let's redraw the smaller triangle separately over here. I am just changing B vertex over here. D will go there. C is already here. This is 70 degree, and this angle and this angle are equal. Why? This is the common angle for both the triangles. Now this 70 degree is equals to this 70 degree. So we can say these two triangles are similar. Because if you observe this way around, okay, 70 is there, 70 is there, then what possible mistake we can make is, what would be side corresponding to CE? We can write down side corresponding to CE is CD. But if you observe this figure, now what is the side? This CE, what is the side corresponding to CE? CE is the side which includes angle C and 70 degree. Side which include angle C and 70 degrees, CB. So the corresponding side to CE is CB. To avoid that kind of mistake, what you can do is always draw a rough sketch of the smaller triangle nearby the larger triangle given, and in the same orientation with the angles in the same direction. So with that you will easily able to identify the corresponding sides. You will not make mistake in that. Clear?